Alright, so this is going to be the next video in the series of going over the week 1 of the June Leetcoding challenge. This is going to be the second problem, interleaving string. I mentioned in the last video that I would like to have completed this like in the deadline that it was during that day, right? Because you only have a day to solve these, I think. But I've been pretty busy with finals in school, so yeah, wasn't able to do it. Got a cram for those exams, you know. So yeah, but today I just powered through all of them. So in this video, I'll be just explaining the problem and the solution and wrapping up with the runtime analysis. So this problem, interleaving strings, essentially it gives you two strings, S1 and S2, and you want to see if you can interleave them to make the third string, S3. And so interleaving the strings essentially means you can basically chop them up and see if you can make string number 3 with 1 and 2 just by chopping them up, but you can't like rearrange it, right? So it's just easy to see with their example. So if they have AA, B, C, C, and DB, B, C, A, you can make this third string here by kind of chopping this guy up, taking this first bit, and then taking this bit from S2, then taking these two guys from S1, and then this guy, and then this guy, right? So you can't rearrange the order of the letters, but you can chop them up into different sizes. So it's essentially like interleaving, kind of intertwining the strings together. And so yeah, so let's go over how to tackle the problem. So right away, you kind of notice like well, at least for me, I the first thought is can you just straight up use like a greedy type of approach where let's just say you know S3 is AAD, and of course S2 starts with D, so you should obviously try S1 to grab these two A's because it starts with AA, so you should obviously grab the A's from S1. But that doesn't work because there are certain cases where let's just say S1 is like B, A, B, and S2 is B, A, B, C, and this is like, I don't know, D, F, or it doesn't really matter, right? And then let's just say our target is like B, A, like B, dot, 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 dot. We don't really know whether we should start grabbing from A right away or if we should start grabbing from B. And furthermore, we could also grab BA from string 1 and grab only the B from string 2, and that would create the BAB that we need to start with, right? But we don't know which one will work, and this could potentially impact what happens, because if we start right away and we just greedily grab these three letters from S1, and sure, yeah, that gets us through here, but this extra section here, like it might be impacted by the fact that you already used up all your letters from S1, and same with S2, and you could even get into the case where you want to grab this one from S1 and these two. Well, that wouldn't really work, right? But you could grab these two from S2, so to start, and then grab this one from S1, and that would also make the BAB required, and you'd have a different set of stuff you can still intertwine, right? So you can't just go gung-ho, you know, oh, I see BAB, let's just grab it all and hope it works. So you kind of have to try all your options, right? So then the solution I stumbled across was, well, if it's a problem that we don't know whether we want to grab this B or this B to start, we can just try both. So we can grab this B, and so we can just have a number that symbolizes the current index we're at in string 1 and string 2. like different numbers respectively, and we could just grab this one, move this number to point to the A here, and the S2 would still point here. We just try that, and we can after we try that, we can try moving the second one over one and keeping this one here, and that essentially says, yeah, we'll take this guy and put it here, and then we'll see if that's possible. So because you might need to take this, the B from S1 or the B from S2, you can just try both, and this is pretty much the right solution, but there's one optimization, but it's more easy to see how the optimization comes into play once we actually start coding it. So let's go over the implementation. So yeah, and it is worth it to mention that you probably at most you want it to be like a n squared, I guess, because it's 100 length. So that's like 10 to the 2, so 10 to 4. Yeah, you don't want anything worse than n squared. Like n is the length of these, right? And so we will start by explaining this little helper function. So as we talked about earlier, there's going to be a string and the index. So int a will represent how far we currently are in A. And the reason why we want these indexes, if it wasn't clear, was because when we interleave, we can't like rearrange. So if we want this, we can only start from the front of S1 and the front of S2, right? So we can grab a chunk from the front, and then only after that we are able to access and put chunks after it into the array. I mean, not the array, into S3, and then we'll see if we can kind of piece together S3 by grabbing chunks off of the front of S1 or S2 and kind of just shoving them into a string, right? And so these indexes will present where we currently are in S1, S2, and S3. So rule number 1 when writing a recursive function. First of all, I should probably explain why we want a recursive function, right? Because of the logic I explained earlier, when we don't know whether we want to take this one or this one, we just try both. So a recursive function lends itself really nicely to that. So we could simply try if this, let's just have a function called like, what is it called? Is interleave. Let's just say is interleave, and then we pass in, we move this little pointer forward one and point to this one. We call it is interleave on that situation, and then we can call is interleave on the other situation where we move this guy over one, and that just makes it really easy to work with, right? So our base case here is uh, the first thing we should mention actually is in our main function here where we're just given these 3 strings. Of course, if the 2 smaller strings don't add up the length of the third string, you already know it's impossible just because of how this problem works, right? Like you need to combine these 2 strings to make this third string, so if the length doesn't even match up, you know it's false, so you can just return false there. So that makes it a little bit easier to not have to worry about like an edge case or something like that in a recursive function. So our base case is when A is when you're at the end of string 1 and you're at the end of string 2 and the end of string 3, that means that you've successfully interleaved string 1 and string 2 into string 3, and you should return true. And otherwise, if you've reached the end of one string, you just need to check if the other string, so substring that'll give the end of the second string, and you just want to check that equals the end of the third, so you can just return that. And same with when you reach the end of string 2, you can just check if the end of string 1 is the same as end of string C. And ignore this part for now, I'll explain what that does later, but this is the important part. So I just made 2 random booleans with pretty bad naming convention, and we just be like, if the character at our current index in string 1 is equal to the one at string the character at string number 3, because C represents the current index we are at, we will move 1 forward in C, and we will move 1 forward in string 1, and we'll keep string 2 at the same spot. So this boolean will represent if taking that character. So if we can take this character, we'll take it and check if we can solve this thing. And same with the second string. And yeah, so originally you can just return like you can just return whether this boolean t1 is true or this boolean t2 is true, because if either of them are true, you want to return true, because then it's possible to interleave the strings, right? But the problem with that is you get a time limit exceeded because it takes a little too long, because the problem is a lot of times when you explore this, right, you will discover a situation where you end up like taking this many in string 1, and then you end up having to take this many in string 2. But there's also a lot of times when you end up taking stuff starting from string 2, and you end up in the same situation, right, where you take and take, and this string could be way longer, right? So you don't really want to have to recompute that. So that's when we just use a little bit of memorization to optimize the runtime. So we'll just have an int array here. It essentially keeps track of 2 numbers. This will represent the 2 numbers you feed into it, will represent where you are currently at in these 2 strings. And the integer it stores, I have in a comment here, 0 equals you don't know if it's possible to interleave when your index is here and here. 1 is you know if your indexes are at A and B, that's a false. And 2 is you know you reach there, there's a true. So yeah, so that's just a little bit of memorization that you have to do. And so that adds into our base case here. So apart from these base cases, another base case is if we've already found what the result is when we are at these 2 indexes. So if this is not unknown, if it's 1, we'll return false, otherwise return true, because we've already calculated this. And yeah, so essentially this saves us a lot of time, because if you imagine a situation where we calculate starting from taking things from the first string, so like is interleave, we increment the first string. If we calculate a bunch, we end up going like all the way here, we take some from the second string, and let's just say you end up having a pointer at this index of the first string and this index of second string, and you do all that work, you find all the way to the end, and it's false. When you go to the second string, and you might end up in the same situation, where you end up in this situation, you don't have to compute all this other stuff just to find out that it's false again. So you want to just be able to say, oh, I know this is false, I've seen it before. So that's why this base case here works like that. So if we've seen these 2 indexes before, we can just return what we pre-computed, right? And yeah, that's the only bit of complicated thing we have to do. And so in a recursive function, if either one of these is true, then we know it's possible to interleave starting from our index of A and B, whatever they might be. So index might be here, A might be here, B might be here, doesn't really matter. If we are at those 2 indexes, we know that we should we should just mark that down. So if either one of these is true, it's possible, mark that down as a 2, otherwise mark it down as a 1. And at the very end, after all this recursion, we'll essentially just return what we calculated at the starting position, because our first call of this function is at a equals 0, b equals 0, c equals 0, so we'll start from index 0, like, of course, since we want to start at the front of every string, and we'll just return whether that equals 2 or not. And so in our main function, this just initializes it to keep track. So this number here, the number you can feed into the first like little bracket, will just be any valid index of S1, and this will be any valid index of S2. So you can just plug two indexes in and see if we've already computed the result. And yeah, we can just return if starting from the front of everything you get an interleaving by calling our helper function here, and then our helper function will recursively try all the options it has. So like if it can take one from here and put it on, it'll try that, and because of these ifs, right? If you can take one here, you try that, and then you recursively call this again, and when you finally finish, you can just record that down and return that. So yeah, so at the end this will return whether or not it's possible to interleave the strings, and we'll run it real quick, and this is accepted. I'm pretty sure the runtime of this should be let me check. So do they say? They don't give any variables, but let's just say m is the length of string 1 and n is the length of string 2. I'm pretty sure this runtime would be m times n, because you could have to kind of check. I'm not sure if it's m times n. I think it is, because you would have to check all the indexes, starting from like each index from both strings, I guess. Because like let's just say you have, this is m, so you have m options for where this pointer is, you have n options for where this pointer is. So like worst case, you end up calculating the result for every pair of m and n. So let's just say m is this pointer here, n is this pointer here. You'll need to figure out if you can interleave starting from these points, and you'll also need to figure out starting from here and here, let's just say, stuff like that. So the worst case would be m times n. And yeah, so that's about it for this video. This is a solution for interleaving string. I hope you guys liked it, and I'll see you guys later. Bye.